Okay, today we're going to be combining two lessons. Um, these two lessons are in your handout, combined into one handout and one set of practice problems. The front side of your handout is lesson 10 and the back is lesson 11. So for the first one, for lesson 10, we're going to be looking at basically two ways to solve an equation. Now, the good part here is there isn't really a wrong way to solve an equation. What we're going to be looking at today is more of like what's the better way to solve it to basically make it easier to solve, make less work for ourselves. So I think you'll kind of get the idea of what I'm talking about here in just a minute. Now remember that we can solve equations that look like this in one of two ways. The first way that we can do, because when we have a quantity here in parentheses, all of it is being multiplied by the number outside the parenthesis. So we can go ahead and distribute the 2,000 to both quantities here in parentheses, or we can just, from the very beginning, get rid of this times 2,000. And that's what we're going to jump back and forth today in lesson 10. So let's look at this first one. Now, I can distribute 2,000 to x and 2,000 to 3/100ths. But that means I'm going to have to figure out what 2,000 times 3/100ths is. And that's not a very obvious solution without grabbing a calculator. So my next thought is going to be, what if I just get rid of this 2,000 times that I don't, and just start from the beginning so I don't have to distribute it. In this case, that is going to be the way to do this. And I can tell that's going to be the way to do it because 2,000 goes into our total here quite easily. So we'll divide this side by 2,000, divide this side by 2,000, and we're left with one of those groups now instead of 2,000 of them, and that is going to be equal to 3. So now that I can do the rest of this in my head, I'm going to add this 3/100ths to cancel this out. I'm doing the inverse operation, and I'm going to add 3/100ths to this side. So x equals 3.03, 3 and 3/100ths. Okay, now that's a much easier way of doing it than trying to figure out some of these multiplication problems and then eliminating them in the end anyways. Let's look at the next one. So everything here in parentheses is being multiplied by 2. We could get rid of that 2 right away. I'm going to look over here at this total. 2 doesn't nicely go into 3.5. So now, instead of dividing everything by 2 to begin with, let's try distributing it. Distributing 2 to these values is not going to be difficult. It's pretty easy to multiply things times 2. So we have 2x, and then we have 2 times 1.25. So I'm going to add 2.5. That's 2 times 1.25 equals 3.5. All right, let's start solving this for x. So we'll get rid of 2.5. Notice I'm doing all this in my head here. So that goes away. 2x equals 1. We're going to have to do, I'm running out of space here, but we'll have to divide by 2 to get rid of that times 2. So x equals 1 divided by 2, 1/2. Okay, easier that way than trying to divide 3.5 by 2 and then do a little more tricky math. Let's look at the next. This one could kind of go either way. Sometimes it's nice to get rid of these fractions because fractions often seem kind of intimidating. If we just get rid of these fractions from the very beginning, that'd be one way to do it. So we would have to divide by 1/4, or we'd have to multiply by the reciprocal. So Since we almost always talk about using the inverse operation, let's divide by 1/4. So we will divide this side by 1/4, divide this side by 1/4. That's going to leave me now with 4 plus x, and I just need to figure out what 4/3 divided by 1/4 is. 4/3. Remember, if we divide, we're actually going to be multiplying by the reciprocal. So instead of dividing by 1/4, we'll multiply by 4/1. And we just multiply across. That's 16/3. Okay. And then we just need to subtract 4 from it. We're going to take 4 from this as well. And x equals 4/3. Take a look at the next two. Decide what you think might be best to try to do these without needing a calculator as often. So look at this -10 here. Now we've got some negative numbers. And decide, is that going to go nicely into this total over here, or would it be better to distribute it to the values in parentheses? In this one, I think it would be better if we didn't distribute, because then we're going to be multiplying everything by -10. We're going to do a lot of multiplication with negative numbers, and it's just complicating things. So let's just get rid of this times -10. Let's divide by -10 and do the same here. So now we just have one group of x minus 1.7. We're dividing two negative numbers here. We're going to get a positive answer here, and that's going to be a positive 3/10. I'm going to write that as a decimal though, because we're going to be working in decimals here. So positive 3/10 is 0.3. I need to do the inverse operation. So I'm not going to subtract 1.7, but add 1.7. And now x equals 2. Okay, take a look at this one. Is it going to be better for us to get rid of this times 3/10, or is it going to be better to distribute it? Well, I would get rid of the times 3/10, because I don't want to have 0.3x, and I don't want to figure out what 0.3 times 8 is. I'm just going to get rid of it. So let's divide by 0.3, 3/10. Okay, that's going to leave me with one group of x plus 8 equal to, and this might be the chance for you to grab a calculator, but 5.4 divided by 0.3 equals 18. Now, if I subtract 8, I can see that x equals 10. All right. For the next part, we have two more situations here. This is where I really want you to try and solve these on your own first, because they follow the same kinds of models that we just saw in the first 5 examples. So decide, are you going to distribute this 4.44 to the x and the 7, or are you going to get rid of it first? Go ahead and solve for x, do the same for the second one, and then we'll come back and talk about it. All right, in this one, I certainly think it would be better, seeing how these two numbers, our total here and this factor, work well together. I would get rid of that first. So divide by 4.44. Do the same here. And that's going to be 2 equals, let's see, where am I? X minus 7. Now we'll just add 7, and x equals 9. Not bad, something you can do without a calculator. On to the next one. So 5 and -13. If I divide -13 by 5, that's going to be a fraction that I'm not going to want to really have to deal with if I can avoid it. So let's try distributing here. Here I'm going to distribute and get 5y. and then I'm going to take 5 times 2/5. Now that works nicely. I know some of you might be jumping for the calculator right away, but we're saying in this fraction, 2 out of 5 parts is what we have. And that works great with 5. I'm just going to take 2 of these 5 quantities. That's 2. So I'm adding 2 equals negative 13. Now we solve. We'll subtract 2. That leaves me with 5x equals, here's where we have to be careful. We're adding 2 negative numbers. No, I'm sorry. We're subtracting 2 from negative 13. We're taking 2 more away. We're getting more negatives, so that's a negative 15, not negative 11. And now we'll divide by 5. So x equals negative 3. Okay, here's the last part for lesson 10. We're going to look at 3 people here, 3 ways of solving the same equation. Okay, we need to decide if we agree with any of their methods and why. And it even has an explanation next to some of their steps so we can see what's happening here. So here's our equation. 2 times parentheses x minus 9 equals 10. Let's look at Noah's method first. So starts off with the equation, says he adds 9 to each side. Okay, and we can see that here. Right away, there's a problem. You can't add 9 to each side because we're not canceling out a minus 9. What we're canceling out is 2 minus 9s. So that's not going to get rid of the quantity that we need to get rid of. That is a wrong step right there. Let's look at Elena. Starts with the same equation, applies the distributive property. Okay, so that's 2 times x, which I see here, and 2 times 9, which is 18. So it's been rewritten using the distributive property. Then she subtracts 18 from each side. So 2x minus 18 minus 18. That's a problem. We need the inverse operation to cancel out subtracting 18. So this should be adding 18 if that's what we're trying to cancel. So that would be a wrong step there. Let's hope Andre did it right. He took the original equation, applied the distributive property, and got the same thing that we just checked with Elena, so we're good there. Now, Andre does the inverse operation, which was Elena's misstep here. He does it to both sides, so that's good. So these 18 should cancel each other out, and we're adding 18 to our total now. 2x equals 28. That all looks good. We want to get rid of that times 2, so we'll divide by 2, balance it on the other side. X equals 14. Andre did a fantastic job. Okay, on to lesson 11. So for lesson 11, we're changing gears a little bit. We're dealing less with distributive property, but now we're using these equations to solve problems. What I'm going to do is go through this first one, then give you a chance to try the next 2. So it says Tyler's making an invitation to the fair. He has already made some of the invitations, and he wants to finish the rest of them within a week. He's trying to spread out the remaining work to make the same number of invitations each day. Tyler draws a diagram to represent the situation. All right, this is going to break down for us in this question each of the elements of the tape diagram here. So the first question, how many total invitations Tyler's trying to make? We're going to fill that in with the number he's trying to make. Well, clearly, our tape diagram has a total of 122, so that would be the number of invitations. Now we're talking about how many invitations he has made already. That'd be the identified quantity here that he has already created. And how many days he has to finish the invitations. Well, based on the situation, it says that he wants to finish them within a week. So counting up 1, 2, 3, 4, 5, 6, 7, we have 7 days, 7 days in a week, will be what we're talking about. And now we need to know how many invitations should Tyler make each day to finish his goal within a week. So now we're solving. First, what we'd want to do is we'd want to get rid of what he's already made, but we have to remove that from the total as well. So we would take 122, remove the 66, and he's left with 56 invitations to still create. Now remember, he's doing that over 7 days. So we're answering not how many he still has to make, but how many he has to make each day to finish his goal. So we're going to take the 56 that still needs to be created, divide it by 7, and that tells us that he needs to still create 8 invitations each day. Now we're going to create an equation to represent the situation. So we know that one side of our equation is going to be that total number of invitations. Then he's already created 66 invitations, and he's got 7 days of the same amount of invitations to make. So 7x plus 66 represents what he's already made and the amount he has to spread out over the week. Okay? Then to solve that, we would just use inverse operations. I'm not going to write that out here right now, but we would subtract 66 from both sides like we did here in the diagram. Then we divide our remaining total by 7, and we would still get that solution of 8 invitations per day. So x equals 8. Now, take a look at this problem. Noah and his sister are making prize bags for a game at the fair. Noah is putting 7 pencil erasers in each bag. His sister is putting in some number of stickers. After filling 3 of the bags, they have used a total of 57 items. Would you take a look at this diagram and see how it represents the information we just read about Noah and his sister? Now let's look at the equation. Noah writes the equation 3 parentheses x plus 7 equals 57 to represent the situation. We need to decide if we agree. So I can definitely see, okay, so definitely it's split up a little bit differently, but we have in this equation telling us that there are 3 groups of x plus 7. Well, if we were to look at this diagram, this would be representing x plus 7. There's definitely 3 of those groups. So yeah, we have 3 of those x plus 7 groups. I think his equation would be great. And it's equaling the 57 total items that they put in the bags. So how many stickers is Noah's sister putting in each prize bag? Explain how explain or show your reasoning. So we could use the diagram or we could use the equation to solve this. Let's solve the equation since we didn't on the last one. All right. I would probably start off, instead of distributing the 3 to both of these quantities, I would just get rid of those 3 groups. Remember what we're doing in the diagram is we're taking this 57 and dividing it evenly into 3 parts so we know the value of each of these parts. That would be 19, because what we're doing is dividing this side by 3 and 57 by 3. So we know that one group of x plus 7, that's one bag, is equal to 19 items. Get rid of the 7 pencil erasers that Noah put there, and what we're left with is 12 stickers that his sister put in each of the bags. Okay, on to the last one. Please read this carefully. This one I want you to do on your own, but read it. If you get stuck, draw a diagram, a tape diagram, or write an equation, and then solve for that missing quantity. Go ahead and check the notes for the information, and have a great day.